Today's video is on writing equations and expressions. You're going to hear the words expression and equation used an awful lot in algebra. An expression has no equal sign. It usually just represents a situation. For example, if you're going to the grocery store and you want to buy 2 apples plus 3 bananas. So you're going to buy 2 apples and 3 bananas. There's the expression to represent your trip to the store. An equation, on the other hand, has to balance. So there's going to be an equal sign in it. So it has an equal sign. So let's take our trip to the store, and we're going to buy 2 apples plus 3 bananas, and it cost us, or it equaled, $2.48. Now we have an equation. So if we look over the different words that you can use in a verbal situation for addition, subtraction, multiplication, and division, there's a lot of different words. Take some time to look these over. So when we're given a verbal phrase, one of our jobs is going to be to write it as an expression. So here we have the sum of a number 2. Sum is addition, so 2 plus n. A number n plus 7. In subtraction, we have the difference of a number. Let's use x for our number. We're doing subtraction. Difference means subtraction. A number and 6. And then the most difficult one, they're going to trip you up on a lot, is when you see the word less than. 5 less than a number. Whenever you see the word less than, you're going to flip these two around. So you're going to do the y first. Y minus 5. That's the same as saying 5 less than a number. Let's just put this into thinking. If I asked you, what is 5 less than 8? Automatically you know that 5 less than 8 is 3. But if you wrote that down on paper, you would write it as 8 minus 5 equals 3. So if you ever forget, 2 ways to remember it. The word less than, it's 2 words, you're going to flip everything. Or just put it into 5 less than 8. I know it's 3, put it in the correct order. Okay, multiplication. We got 1/3 of a number. Now the biggest thing you're going to see, not the biggest, but something you're going to see an awful lot in algebra is the word per. And the sooner you learn that per means multiplication, if you can get those two connected in your mind, then it makes it very simple. 5 per each number means 5 multiplied times the number. And then finally division. We got the quotient, which means division, of a number, and 2. Okay, so let's do some practice using x as our number. So we have 8 more than a number. So we have our number, which is x, and we want more than that, which is addition. We want how many more? 8. Now we have the difference, which is subtraction of 7 and a number. So 7, and we subtract our number. Remember how I was talking about the word per? That means multiplication. So $6 per hour. X represents our hour. 2 more than twice a number. So let's start with our twice a number. Twice means double, so 2x. And then we want 2 more than that, so we want to add 2 onto that. Here we have another per. We got 50 cents. Let's make that big. 50 cents per mile, which means multiply our miles, x, times 50 cents. Okay, here's our little less than thing, the thing that we have to pay a lot of attention to. It's the one where we're going to flip our number and our 7. So the number goes first, that's x. Less than, we're talking about subtraction, 7. And then the last one, 8% of a number. Of a number means to multiply. So if we write it out, it's 0.08. That's 8% of a number. Okay, the big words to look for in a verbal sentence that'll get you halfway there is the word is or is equal to, because if you see the is, you can immediately put an equal over it. So equal or equation means total. So let's do a little bit of practice. We got 10 more than a number is. See, right there, they gave it to us. Is our equal. So we have our equal sign here, so we have equal 62. And on this side, we have 10 more than a number. So we have our number, x, and we want to do 10 more than. So 10 more than a number equals 62. So when we're evaluating a verbal description, it's best if you can go ahead and do some marking up of the information it gives you. So we know that we're being charged $25. And then the only thing that we're doing with that $25 is adding it to something. So plain old 25 plus something. And the plus something is $1.50 per mile. Remember that per mile means multiplication. So we got an addition and we have a multiplication. So when we look at this, we know that our $1.50 has to be multiplied times m, which is our miles. So if we look at this first one, is $1.50 being multiplied times m? No. So this one can't be correct. In this one, our $1.50 is being multiplied times m, which is what we expected, and our 25 is all by itself. So this one represents it. But let's look at this last one. Is there anything in our language that says that we need to add plain old $1.50 to $25 and then multiply it times the miles? Well, when you first look at this, sometimes people say, okay, we got to do 25 times $1 plus $1.50 and then try and multiply it per mile. But remember PEMDAS. Before we can do our addition, here, we have to take care of our multiplication. So this one does not follow PEMDAS. And there's our answer. Okay, so now let's look at our second one. Same thing. We know that Joe purchased a $25 meal card. And then here's our key word. It's when he buys lunch, it's deducted. When he buys a drink, they're going to charge him for a drink. So both times they're taking money from his meal card. So when we look at our two examples that were given, this one and this one, does this example talk about deducting and subtracting and charging? No, it's adding to his meal card. I want that meal card. But in reality, Joe's meal card, when he buys a lunch, they take away $2.50. When he buys a drink, they take away another $2.50. So that's the answer. Okay, so now let's look at Matthew and his U-Haul truck. So he's paying a flat fee of $75 plus he's doing 30 cents per mile. So we know that's our multiplication. And look, it's already given us part of our equation. C is, and what is it that we know? We know it's $75 plus 30 cents per mile. And we're using m for miles. So that's our equation. To evaluate means that we're going to substitute in for our variable so that we can find the value of an expression. The biggest thing for you guys to realize or do, this is just going to be something you do from now on. So star this, underline it, use parentheses when you're substituting. So what I mean by that, we have this first one, and it's giving us our values for A, B, and C. So we know we have a -3, but now we need to substitute in for A. So I'm going to use parentheses. My A value is 12. And then I still have to square it. Now I can evaluate it. Everything is in the correct order. So according to PEMDAS, I'm going to have to take care of my exponents. So 12 squared is 144 times negative 3. And negative 3 times 144 is 432. Okay, so let's do it again. We've got 2, but now I'm going to use parentheses to substitute in for C, which is 4. Now I already have parentheses in my equation, so I'm going to go ahead and put those in blue, but it wants me to substitute in for my, don't want to do it that way. Let's do it in red. So I'm going to substitute in for my A, I'm going to substitute in 12, and then plus, for my B, I'm going to substitute in 9. And I'm going to go ahead and close my parentheses. Okay, so according to PEMDAS, I'm going to start with inside my blue parentheses, or inside my grouping, which is 12 plus 9. And 12 plus 9 equals 21. We're going to multiply 21 times my 4 and times my 2. So when I multiply 2 times 4 is 8 times 21, my answer is 168. Okay, let's do one more. We got A is 12 minus C, which is 4, close my parentheses, plus, that's a plus sign, B, which is 9. Okay, I'm going to start out by evaluating inside my parentheses. 12 minus 4 is 8, plus 9 equals 17. Okay, so now let's do our table. Our table, we're given the values of our x that we're going to substitute in right there. So our first one, we have y equals, so let's do y equals 2, but instead of x, I'm going to use my parentheses and substitute in my negative 1 minus 3. So let's go ahead and do this over here on the side. 2 times negative 1 is negative 2 minus 3 equals negative 5. So my y value is negative 5. Now let's do it again. Y equals 2. And this time what I'm substituting in is I'm going to substitute in the x value of 0. So instead of a 2, I'm going to put, or instead of an x, I'm going to put a 0. And then I'm going to say again minus 3. So evaluating it over here at the side, 2 times 0 is 0, minus 3 equals negative 3. So my value is negative 3. Okay, last one that we're working on is Corey hiring a band for his birthday. So Corey hires this band for his birthday. Let's go ahead and look at it. We got a flat fee of $250 plus $100 per hour, which will be multiplication. So let's write an equation where C is. So let's go ahead and say C equals. And that's the total cost of his band. The total cost is going to be our $250. And we have it written right here, $250 plus. So $250 plus. And then we know that it's $100. And we've already figured out that per means multiplication. And they've told us that our hours or our time is T. So 100 multiplied times T, so 100T. Now let's actually evaluate what if the band is going to play for 4 hours. What's it going to cost us if the band plays for 4 hours? So our cost is going to equal $250. That happens every time, plus $100 per hour. But now what are we going to substitute in for our time? We want to substitute in 4 hours. So our cost equals 250 plus 100 times 4 is 400. So our cost equals 250 plus $400 is $650. Remember to put your name on the notes and bring them to class, and we'll see you soon.